This is Neil Schneider for MTBS-TV at CES 2020. Always looking for amazing things, and this is no different. To my immediate right is Dr. Reuven Bakalash. He is CEO of Adshir. Welcome to the program, Reuven.
Welcome. Thank you.
So what does Adshir do?
We are doing ray tracing for gaming, for VR, for AR. And ray tracing is something which makes the games immersive. This is the way to make them immersive. And ray tracing is, to give you the idea, everybody saw the Avatar film. Avatar film is something which is completely virtual. I mean, the features in the film are completely virtual, but they are made, they look very realistic. So ray tracing is a graphics which is fully photorealistic, and this is very expensive in terms of time and money. So it is used in films, but recently everybody talks about bringing down ray tracing to gaming. Now, gaming is something different because this is real time. This need real time animation. This need to make everything in real time. What does it mean? If Avatar took 40 hours to create a single image out of 24 images a sec and so on, now it's much faster. Today they do it in minutes, in hours, but this offline takes hours. Now you want to bring it online to make it real time, which means instead of few minutes, you make it in 10 milliseconds. This is something which was considered impossible just 2 years ago. And you know, I know ray tracing a long time. I was teaching at Stony Brook, New York, and Hofstra, New York, and this was many years ago, and people loved ray tracing, but they say that ray tracing is the future, but it always will be. Why? Because of the high complexity. So you can make it on high-end computers. You couldn't make it on low-end, even on PCs. Now, today is different.
Now, you're being a little bit modest as far as what Adshir is doing with ray tracing. So for those unfamiliar, as you described, ray tracing is a computationally very expensive process, right. And it really works with light in an elaborate way, I'd say. Now, what Adshir is doing is it's not just about working with ray tracing, though. It's about, I think, partly how you're working with it and where it's being enabled. Can you elaborate a little more on that?
Yes, of course. I would love to do. What we have done, we kind of went out of the box to create a new ray tracing, real-time ray tracing, real-time animation, and this is done in software only, which means this is cross-platform. It can run on all GPUs, on all CPUs, all machines, all levels. So this is a kind of solution for scalability. The vertical scalability, which means going from the high-end machines and moving to low end. Now low end, the lowest end of course is smartphones. And we are the only one in the world today that are able to run ray tracing on smartphones.
So when we're talking about scalability, maybe we should elaborate a little more as to what you mean by that. So if I'm a content creator and I'm an application creator, normally maybe I work with the PC market. Okay. Will this expand my horizons?
Right. So we can talk about the vertical scalability, which I just mentioned before. There's also a horizontal scalability. Why? Because you have different makers of GPUs and so on. Now, if you have a solution for real-time ray tracing on a specific a GPU of a specific vendor, you can do it on this one, but you cannot do it on other GPUs. Now, if you have a software which is able to run on any GPU of any vendor, cross-platform, horizontally you can run on different GPUs, and you don't have to buy a specific, more expensive, and so on. It's run on all of them. So this is the scalability. Now, there's another point. I would say that once you have ray tracing for games, to make immersive games, that's what we are working on. We have it already. Still, it's not a product, but it's a very new and revolutionary technology. By the way, it's patented. We have 24 granted patents in the US and more pending and more in pipeline. So let's say that once you have this ray tracing on all this scalable line, you can make immersive games. Now the question is how good it is for games. Now today you can take an old game and to make on it ray tracing. You can take a new design, a new game with ray tracing, but then it's something which is nice to have. Because the ray tracing makes you beautiful things, and this is very nice, and this is nice to have. But if you are the shooter in the game, you want to make it fast. It's not very important to have it nice. So I expect that in the near future, a new kind of genre, gaming genre, will developed, which will make ray tracing as part of the plot, part of the game, a tool in the game, in such a way that you cannot play without this. Or if you play without ray tracing, you lose.
So maybe we could have a working example. So what I'm hearing is, of course, ray tracing makes things look great. Okay, like it's normally computationally expensive through other means. You get all this wonderful lighting, things look beautiful. And what I'm hearing is that it also adds an element to the gameplay. Maybe you could give an example of how ray tracing could influence how a game is played versus how a game has to be played without ray tracing.
Okay, for example, reflectiveness. It's one of the main features of ray tracing. Now, if you want to make a reflective image out of what is going on the stage, you can make it with ray tracing only. Now imagine you are the player and you have a wall and you suspect that behind the wall there is someone that wants to shoot you. But you are not sure. You want to see him, you cannot see him, because if you go to look at him, you will be shot. So what's the solution? For example, if you have something, a vase, a hidden vase in the corner, and this is a kind of concave image on it, mirror, or something glossy, but you can see someone that is moving on the other side of the wall, you are hinted. So you have the advantage of using ray tracing. If your opponent doesn't have it, he will lose.
So what I'm hearing is, by using the ray tracing technology, you may see details in the game that otherwise wouldn't be seen. Right. So you might have cues that someone's around the wall or someone's nearby that maybe in real life we see, but until now we haven't had the technology to see.
Exactly. So this is a great tool in gaming, something that doesn't exist today. There's no something like this. So I I expect that once we have our ray tracing going into the games, this will be the use which will revolutionize the gaming. So everybody will must to have it. So it's not nice to have it anymore, it's must to have it. And that is going to happen, I think, very soon, in a year, 2 or 3 years.
All right, good stuff. Now, I want to rewind a little bit, because what we talked about earlier in our discussion was not just that ray tracing will work on powerful PC computers. Through your technology, it works through mobile devices as well, which is a first, at my understanding.
Right.
So, question I have is, how does the quality compare?
Right. So, you see, this is not the same quality, not the same performance, but in general, this is the same game. If you have something running on high end and runs fast and it's very beautiful, very nice and so on, and you want to run it on a mobile, of course this is a small machine. So what you do, you can change the game. For example, less triangles. You can adapt it to the low end, and then it will run the same speed. Maybe some of the features it will not have, it can happen, but still you can play it. So if you start playing at home with a high-end machine, then you have to go out and you have a mobile with you, you can go on playing, okay? So this is very important. This is, yes.
So what I'm gathering is that, I mean, if you have a high-end computer, like a high-end PC, and you're using this technology, it could be qualitatively better. Like, you could have a better image. In mobile, you still have that functionality. It's still ray tracing where ray tracing wasn't before. But there could be some quality trade-offs because it's mobile, which is to be expected.
It's a basic, and then you have on the high end, you have extra, of course.
So your solution, does it deliver that qualitative difference between all the different types of computing?
That's exactly what we have. We have a software solution which can run on different levels of machines. We run it actually on low end, on smartphones. We run it on tables, on a tablet. We can run it on high end, on consoles, and so on. So it's scalable vertically. But also, because it is a software solution, a pure software solution, it can run horizontally on all the GPUs. It can run vertically on the most powerful computer or most powerful GPU, like NVIDIA, AMD, and so on. You can run in the low end on the Mali, on Qualcomm GPUs, which are only fragment of the power of the big ones.
So I'm not sure if you're going to be able to answer this question willingly. Yes. The first question, we know that ray tracing is computationally expensive, and clearly because you're the first to do it, it's unique in that respect. So the question I have is, how? Like, how is it possible to deliver ray tracing in a low processed form factor? I mean, you don't have to go into the fine IP or all that stuff, but is there a change in methodology? Like, why is it so challenging for others versus in this scenario?
Right. So let me tell you, from the beginning, my intention was to solve the problem of real time, to make ray tracing for real time. It wasn't existing that time. So, and I started in 2010 or 2011, something like this. So it must be, first of all, high performance, real-time performance. Second, it must run real-time animation. Because if you don't have real-time animation, you cannot make it. You cannot make games. Now, at that time, ray tracing was based on a static data structure. it doesn't matter what for, but it was based on static data structure. And I decided that if you want to make it dynamic, you have to change the data structure. And this was a research of few years. And finally, I found the dynamic way to do it. So today, we remove the static data structure, which everybody uses today, and we have a patented dynamic data structure. We call it DAS, Dynamic Accelerating Structure. And this makes the difference. There are a few other differences, but this is the main difference.
So what I'm hearing is the methodology changed. It was really, you broke it and rebuilt it, as far as ray tracing is concerned.
You can say that.
Okay, wonderful.
Right.
Well, it's really exciting stuff. I mean, can people start using this today? Like if developers are interested, how do they go about using it?
We are going to be with the product in few months.
Okay.
On different levels. But we started from bottom up, so from mobiles, and it will happen very soon. You will see it on the market, I think, during 2020.
All right, wonderful. Well, thanks so much for joining us.
Thank you very much.
This is Neil Schneider for MTBS-TV, and of course, we will be back with more. Thank you for joining us.